In this video, we are going to look at calculating the coordinates of points around a circle like this in an effort to help us to better understand our trigonometry ratios. So we are going to look at the 45-degree angle of rotation and the 120-degree angle of rotation. So what we're talking about here is you've got a circle, and if we start with a radius going straight out horizontally like this from the origin to this point on the x-axis, this is a 0-degree angle of rotation. Now if I take this same radius and shift it up to there, that makes for a 30-degree angle of rotation. And so when I'm talking about angles of rotation, that's what I'm talking about with these. Now I'm going to look at two particular angles of rotation, and we're going to start with the 45-degree angle of rotation. And if I want to find the coordinates of this point, I need to know how far over and how far up I go to make that. So I'm going to draw a perpendicular line segment here back to the x-axis to make my right triangle. Now this should look very familiar because this is actually a slope triangle. You've got your delta y and your delta x going on here. Now the question is, how long are each of those segments, because that would be your x-coordinate and your y-coordinate for the problem. If you look really carefully at this document, you'll notice that it has a scaling on the vertical axis. This is 0.5, this is 1, which means that the radius of the circle is 1 unit, whatever that unit may be, which means that a 0-degree rotation, this point would be 1, 0. That also makes this radius right here 1. Now I'm going to start with the 45 because it's one of the triangles we should be able to work with the most easily. So to find the coordinates of the points, I need the x and the y values. So I'm going to look at this triangle outside of the circle for just a minute to figure out how long each of those pieces are. And my right angle. I know that my hypotenuse is 1. I know that my angle down here is 45 degrees. That was the angle that I rotated that radius. Well, if this is 45, then so is that, which makes this an isosceles right triangle. And so when we're looking at the lengths of the two sides, we can call them both x. At this point, we can either remember the ratio for the isosceles right triangle, which is where we're hoping you're going to get to, is that you will be able to just have these ratios memorized. But in case you don't, you could always do Pythagorean theorem. So we've got x squared plus x squared equals 1 squared. Making 2x squareds equals 1, divide by 2, x squared equals 1/2, and then we square root both sides. Now remember that because this is the length of a side of a triangle, we are only going to worry about the positive version of x. So that's the square root of 1/2. Now in general in math, we tend to not like having fractions inside radicals. So what I need to do is something called rationalizing this, which means I need to get the bottom of the fraction to be a rational number, and integer is where I'm going to be shooting for, and the top of the fraction can be whatever it wants to be. So the way to do that, if you have the square root of 1/2, is to remember that with square roots, when you have division or multiplication inside them, you can rewrite them as two separate pieces. So this is the square root of 1 over the square root of 2. Square root of 1 is 1. So this is 1 over the square root of 2. Now in general in math, we don't like to have the square root in the bottom of the fraction, so the way to get rid of that would be to multiply the bottom of the fraction by itself, which has the effect of squaring the bottom. But because this is a fraction, we have to do the same thing to the top as we do to the bottom. And squaring would not be the same thing, so what I'm actually going to do is multiply by the square root of 2 over the square root of 2. This is 1, so that means I'm not changing the value of this, I'm just changing what it looks like. I multiply across the top, 1 times the square root of 2 is the square root of 2. Square root of 2 times the square root of 2 is 2. So then my x is going to be the square root of 2 over 2. Now if I look back up in the circle again, this x was this horizontal piece, so I know that the length of that is the square root of 2 over 2. That's my x coordinate. And then my y coordinate, since this is an isosceles right triangle, is actually the same. Square root of 2 over 2. So that's for the 45. You do the same kind of thing for 30 and 60 with using their ratios. Now, a reminder about the ratio here is that when you have an isosceles right triangle like this, a 45, 45, 90, the ratio between the parts is, actually let's do a different letter, A to A to A square root of 2. Now we're going to look at a different angle. We're going to go into the second quadrant and we're going to actually look at an angle of rotation of 120 degrees. So there's my angle of rotation of 120 degrees, which is going to give me this radius in the circle. Now if I want to find the coordinates of this point, I'm going to be looking for a right triangle again. The right triangle, though, is going to be drawn right here. All right, so if we think about coordinates, start at the origin, how far over and how far up. Now, as we're looking at this initial triangle, we'll look at it over on the side here. We know the hypotenuse is still 1 because it's still a radius of that circle. This angle is the angle we're going to be looking at. And that's the angle that's in here. Now if I've rotated this radius 120 degrees, that means that the number of degrees that are left to get back to the next x-axis is going to be 60 degrees. So this is a 30-60 right triangle. And in the 30-60 right triangle, if the hypotenuse is 2a, the side opposite the 30-degree angle is going to be a. The side opposite the 60-degree angle is going to be a times the square root of 3. That goes back to when we looked at the 30-60 right triangles. Remember that we could make a copy of the 30-60 right triangle over here and turn this into an equilateral triangle. If we did that, which would give us a whole side length of 2a here, 2a here, 2a here, but this breaks this side in half. So that's why this is a, and we can do Pythagorean theorem to get a root 3. Now in this triangle, we know that 2a equals 1. So divide by 2, and this is the faster way than doing the Pythagorean theorem to do this. You now know that your a side is 1/2. So back up in our circle, we know this side is 1/2. But now we want a coordinate for that. And since we're in quadrant 2, the x values are actually in the negative direction. So when I put my coordinate up here, it's negative 1/2 for that. The a root 3 side, that's the vertical side here, is 1/2. So a root 3 is equal to 1/2 times the square root of 3, which we tend to write this as a single thing. So the a root 3 side is the square root of 3 over 2. minus the square root of 3 over 2 in our picture. This is still an upward motion for the y-axis, so the coordinate is root 3 over 2. You're going to go around and you're going to do that for each of the other marked angles on here, figuring out what their coordinates are, and then you're going to fill out that table in that sheet. So I hope this has helped.